Hello, welcome to 253 Process Troubleshooting. Today we're going to start Chapter 6 and we're going to talk about absorption and stripping. Okay, so this will be the first part of it. I may take longer to do this in 15 minutes. This is a little complicated process. I'm going to make sure you understand it. So I may have to stop somewhere when it gets close to 15 minutes and then do another part, okay? But I'll try to do it in 15. All right, so we'll talk about introduction, and we'll talk about the learning objectives and the process description. So initially we're going to learn what actually an absorption process is and a stripping process are. Then we're going to explain the factors that affect these two processes. And then, given one factor that affects absorption or stripping, we'll discuss the possibility of how it affects other factors. Okay, normal thing. So this is an older picture of the absorption and stripping, and I have some newer ones in there, so I just want to show you this right now. All right. So absorption is a form of gas separation. It provides the medium for a specific material to be absorbed. It usually occurs in the gas phase. The desired material to be captured is absorbed by the material while the other components of the gas mixture are allowed to pass through. So in this class of the absorption process, bottom's material from the distillation column is the absorption medium to absorb the vapor catalyst from a mixed vapor stream from the reactor. Stripping is the removal of unwanted materials from a process stream. Now it can be accomplished using air or steam. Air stripping columns are most widely used for removal of VOCs. They're called volatile organic compounds, and usually from water. Steam strippers allow for the removal of heavy soluble organic compounds, heavier than these, from a liquid stream that air strippers can't do. In the class stripping system, catalyst that has been absorbed in the distillation column bottoms will be removed by sparging with steam. So we're going to use steam stripping. The catalyst will then be recycled for reuse in the reaction process. Okay, so when you use these two together, okay, they're used very efficiently to separate, recover, and reuse valuable materials from a process stream. But if they were left in the mixture, they're useless. That's what that really is all about. That's why we do absorption and stripping. So our absorption stripping process recovers the catalyst vapors from the mixture of the gases leaving the reactor. So that's the whole goal of what we're doing here today. The catalyst must be separated from the waste gases and nitrogen to recycle it back to the reactor. Okay, so this is from your picture in your book, Figure 6.1, and that's page 6-23. Okay, now the next page, I want to talk about the flow first. So even though we're not going to really talk about all the normal operating conditions, I do want to talk about exactly how things start and where they go so that you can understand this. Okay, so let's start with the equipment first. D2 is the actual stripper, and D3 is the absorber. Okay, E6 over here is the lean absorbent chiller. Okay, we'll talk more about that. And E7 is the rich absorbent chiller. Okay, and S3 is the liquid gas separator, and it separates the vapor catalyst from the condensed liquids. All right. Now it starts off, we take the feed from the reactor. Okay, so the reactor gas is coming in. Okay, so this is number one. We flow into the absorber in D3. We place that at the bottom. Okay, so it's going up the column. Okay, we're coming down the column, so that's going to be number 2, is the absorption fluid, and it's from the decanter. Okay, remember the decanter way back? It comes down this line here, goes through here, is fed through this line here all the way through, goes through this E6 chiller, all right, and then comes in the top of the column. All right, so then the column, that liquid traps all of those gases of the vapor, and then it pulls it out through here. So it becomes catalyst-rich absorbent. So that's number 3. So this comes through here, and that also goes through a reactant. Whatever of the vapors come out of them, they come through here. That could be the vapor catalyst captured and sent off here. But first, it goes through the other stream comes through the stripper. All right. So the cooled, the catalyst-rich absorbent stream goes into the stripper D2 at the top of the column. Okay, and it goes through. Now, steam here, 200-pound steam, comes through this stream at the bottom through a sparger. So a sparger is just like a coiled tube, a really large tube with holes in it, so that it just spits out the steam, and you get a lot of really good distribution and really good transfer here. So then the steam comes up through the top, and then it captures also some of the vapor again, goes through here, and then you get the vapor catalyst comes off the top. Down at the bottom, number 5, is there's no vapor catalyst here. It's pumped by P6, comes up through this line, and then some of it is the blowdown. So it goes to the decanter, all right, back to the decanter. So you may lose a lot of absorbent fluid here, but we do go back to the decanter where we do that separation process that we did in the very beginning. Okay, now I want to show you number 6 is over here. Hold on a minute. I have to find my number 6. Is, I can't find it over there. Here it is, the blowdown. So that's what number 6 was. Sorry, we just talked about that. So number 7 then. So we come over here, and this vapor catalyst goes into the separator. So it's separated from the liquid and pulled off to be recycled back to the catalyst to the reactor. So remember, we had the reactor with a makeup line as well. So that's number 7. And then we also have here anything that is not important, okay, none of the catalyst, there's still vapors that come out of this absorber. It goes off to the waste as a waste gas to the incinerator. Okay, so this is a little confusing, but I wanted to talk you through that. Okay, and this is another schematic, an older one. You might like that one better, I don't know. I like the one that we did. Okay, our absorption process description. So reaction gases are introduced to the absorption column D3 close to the bottom, which we talked about. From there, the gases travel up the column and contact the liquid absorbent. So the absorbent is that organic liquid from the reactor, and it passes through the decanter and distillation processes. It's fed at the bottoms of D2, that stripper, and then the makeup from the decanter at the top of D3. Okay. The absorbent flows down the column, contacting the vapor and absorbing the catalyst. The unwanted gases pass through the absorber and out to the waste gas destruction facility. So you can take that picture that I had shown you and I had labeled all the different numbers, and you can follow this along if you can print that out sometime. The bottoms of the absorber column, D3, which are rich in the catalyst, are referred to as rich absorbent fluid. So these will be in some of your questions on your self-study questions. The catalyst-rich absorbent is pumped through the rich absorbent catalyst vapor heat exchanger, E7. It is preheated by the vapors for a stripping column. This preheated flow then goes to the top of the stripper column, and the stripping is then there occurs. Okay, again, just some more showing you here. All right. We're talking about this D2 here. Okay. In D2, the stripping column, the catalyst then is stripped from the rich absorbent fluid with the sparging steam. Okay, we talked about that. Now, it's important to note that temperature and pressure are controlled to maximize the separation of the liquid and the vapor. The bottoms from the stripping column no longer contain the catalyst and are cooled through E6 and fed back to the column top of the absorption column D3. In D3, the vapors from R1, the reactor, again continuing to be absorbed from the bottom up. Any liquid that is condensed in E7 is separated in the liquid gas separator, S3, before the catalyst is recycled to the reactor. Okay, so that's basically the whole continuum. Now there's a blowdown from the stripper bottoms sent to the decanter for the condensate removal. A considerable amount of absorbent is lost with the condensate in this blowdown. The lean absorbent fluid makeup is added from the distillation bottoms as needed. Okay, so another picture again of that. All right, let's talk about the factors now that affect the absorption process. We have 3 of them: temperature, pressure, and flow. Temperature. Now, low temperatures facilitate optimal absorption of a gas or vapor in any absorption process. Remember, gas solubility always decreases with increasing temperature, right? Think about it. If you have a bottle of soda and you sit it outside at room temperature, right, the bubbles come out. If you stick it in the refrigerator, the bubbles stay in, and that's why you always keep your sodas in the refrigerator cold. At high temperatures, the material to be absorbed is more likely to remain a vapor, thus recovery is minimized. Just what we talked about. High pressure. High pressure in the absorption system increases the contact between the liquid and the vapor. Increased contact improves absorption up to the point of saturation. So remember, saturation is the most amount that you can get inside of the solute inside of a solvent, okay? Gas solubility, this is Henry's law. The solubility of gas is increased with increased pressure. Flow. There must always be enough absorption fluid to absorb the desired component of the gas or the vapor flow. A balance of these flows is important to ensure that the absorption fluid can absorb the vapor stream. Okay. If the absorption fluid becomes saturated, it is not effective. So if you have it just too much full, right, where it's not going to have anywhere to go. It's like if you take your coffee and your sugar in the morning and you put too much sugar in there, it won't absorb it anymore, right? It becomes saturated, and then it's just wasting sugar. So you're just going to leave behind the extra amount. So we have to make sure we keep this flow constant at the right ratios. All right, let's talk about stripping. There are also 3 factors affecting stripping: temperature, pressure, and then flows and levels. Same thing. Now, stripping and absorbing are just little different operations, but they go together. Now, to ensure optimum conditions in stripping, a high temperature is needed to liberate the absorbed vapor. In this case, the opposite. In our stripping process, steam from the steam generation process at 10 psig is used. High pressure steam is used for makeup. Low pressure is normally maintained in stripping systems to minimize the energy required to strip the vapor component from the rich absorption fluid. And then flows. Flows and levels must be maintained as dictated by the process. The volume of a rich absorbent fluid is directly related to the requirement for the heat energy input. It's important to note that. Okay, so that's it, and I don't want to talk any more about this because I think, I don't want to do another slide because you'll have a test for your distillation process, okay, Chapter 5. So do your self-study questions on page 16. So answer those questions, and always remember to keep working on your bioethanol project, okay? That's due in the final week, all right? We only have a couple more weeks left. So hang in there, guys, and I'll talk to you soon.